This is College Algebra Unit 3, Section 1, 11 on to the end, and then Unit 3, Section 2, 1 through 10. The first questions are finding the domain. The domain is very important as far as what you can put in for x. The only thing you have to worry about is if you have an x in the denominator, like number 13, that denominator cannot equal 0. Number 11, there was no x's in the denominator. Also, another thing we have to be concerned about is square roots. Square roots have to be 0 or positive, like this in here. 2 minus 3x has to be greater than or equal to 0. And then we work that out. So x, it ends up, because we had to divide by -3, is less than or equal to 2/3 for the allowable x's. Number 14, all real numbers, because there's no x in the denominator, no square roots. 16, we have a square root, so that x has to be greater than or equal to 0. 18, we have x's in the denominator, x squared minus 3x minus 10. We are not worried about the numerator at all when we're doing domain. We have to factor the denominator, which I have done here. Factor it, and then we get our two numbers. On number 20, we have no x in the denominator, no square root, so we can put all real numbers in there. Okay, 21, 22 here. It is a radical, yes, but x squared plus 16 has to be greater than or equal to 0. And then when we move that 16 to the other side and take the square root, we're taking the square root of a negative number. So we're not going to get any real numbers here. So all real numbers will go in that, because there is nothing that you could put in for that x that's going to make it negative, because you're squaring everything. 24, two things to consider. You've got a square root. So x has got to be greater than or equal to 2 from it, plus the denominator can't have a 5 in for that x, because you'd be dividing by 0. So all real numbers greater than or equal to 2 plus not 5. Okay? Then on 25 through the end here, we are putting numbers. We know that f of x equals 9, so you'll put 9 equals 2x minus 3, like I did on 26. F of x equals 3x minus 17, and your f of x is -5, so -5 equals 3x minus 17. Then we work that out all together. We find our x is 4, so that means f of 4 equals -5. So on all of these questions, we're setting, like on the next one, 19 would be equal to x squared plus 3. Then you work that out and find your two answers. On 28, x squared plus 3x minus 5 is your function. It is equal to 13. So 13 equals that. And then since you've got a squared, you make it equal to 0. X squared plus 3x, move that 13 over, makes minus 18. We factor, and we find our two numbers. -6, f of -6 is 13, and f of 3 equals 13. Same thing, 28, x squared plus 2x plus 7 would equal 31. Then you work it out. 30, f of x is the square root of 3x plus 1 will equal 4. So we have to square both sides. Now, you need to be careful here. I didn't show the check, but you should check when you square an equation. F of 5 equals 4, because it would check. Number 31, make sure you realize you're going to have two answers. The absolute value of 2x plus 3 equals 15. So you're going to set 2x plus 3 equal to 15 and 2x plus 3 equal to -15, and you must show that work. Then, number 32, f of x equals 2x minus 3 over x plus 9. It's going to be equal to 1/2. So then we cross multiply. X plus 9 times the 1, the 2 times the 2x minus 3. Notice we get x plus 9 equals 4x minus 6, and we work it out. We find our x is 5. F of 5 equals 1/2. The next section, Unit 3, Section 2, we look at the graph. Like on number 1, your graph goes from -2 up to the left and from 2 up to the right. Tell what the domain is, what the x's are that are used there, the x's. The y's are the range. You tell them also. Like number 2, here's our picture. From -3 around to +3. So the x's are from -3 to 3. The y's, the lowest y coordinate is 0 up to 3. So 0 is less than or equal to y is less than or equal to 3. Those also could have been written in interval form, -3, 3 in brackets for the first one. The second one, from 0 to 3. The next page, I did draw 3 out kind of, but I'd look in the book, it's a little more well done. Number 4, I've drawn out here the domain. No, it goes forever to the left and forever to the right and doesn't skip anything. So the domain is -infinity to infinity. The range is the y coordinates. It goes down forever, so that's -infinity, and then it goes up to 2 there, stops at 2. Number 5, I've shown here roughly. Number 6 starts at -3. So the domain starts at -3, bracket -3, and then it goes forever to the right, so that's infinity. The range, the y coordinate, starts at 0, goes up to infinity in this way. 7 I didn't draw. 8 I made a rough draft of it. Notice the x's, -infinity to infinity. It goes forever to the left, forever to the right. The range goes down forever, so -infinity, but the highest point is 2. Number 9, graph in your book. Number 10 is a little bit, you've got to watch it. The domain starts at -infinity because it goes forever to the left, then it comes up to here, and you think it stops there. Not really. It starts again up here at the same place, doesn't skip any x's, then goes to the right. So -infinity to infinity. The range, though, started at -infinity because it went down forever, comes up to this point here, doesn't equal that point though, so I put a parenthesis there at -1. Then it goes up here and starts again at 2, bracket 2, to infinity. That concludes this assignment. Make sure if you've got questions you ask.